The law of conservation of matter states that you must have the same amount of reactants as products, correct? Matter can neither be created nor destroyed. You always have the same amount. So, can somebody tell me what my reactants are in this equation? Clea, can you tell me which ones my reactants are?
The ones on this side of it.
So the ones on the left side of the equation, okay? You're not going to know what these are called yet. We're actually going to talk about naming compounds a little bit today, okay? So these guys here are your reactants. So where are your products, Destiny? On the right side. These are your products. Okay, so now I'm going to pause the video. I want you to take a little bit of time, get some paper out, and I want you to work this out. When you have a bracket, it's just like exponents. So in this case, I'm going to take the FeOH, and the OH is in a bracket, and there's a 3 at the bottom of the bracket. What this means is that in this case, there is going to be one Fe, because there's only one of these guys. There's no number down here, and there's no number in front. But the OH, it's like saying that you're multiplying this by 3 and you're multiplying this by 3. Okay? So I want you to work this out. Tell me how many elements there are on the reactant side, how many elements there are on the product side. List the elements. Then you're going to tell me how many atoms of each there are to see if it's balanced. Okay? So hopefully you've had some time to work through this. Now, we're going to do this together and you can compare your answers. So first things first, we need to make a column of all the different elements that are on the reactant side. Okay? So, give me some elements. Give me the first element. Does anybody know what Fe is? Do you know what it's called? Iron, right? We've got Fe here. How many do we have? We have 1 because there's nothing written there. Okay, there's no number. If there's no number next to the element, we assume that there is 1 atom. Then Cl. What is Cl? Does anyone know? Chlorine. How many chlorine? 3 chlorine. Next. What do we have? What is Na? Sodium. How many? We have 3 because the big number here gets multiplied by each of these elements, okay? So then we have O, which is, we got 3. What does O stand for? Oxygen. Then we've got hydrogen, right? And we've got 3 of those. So on the reactant side, we have 5 different elements: iron, chlorine, sodium, oxygen, hydrogen. And then we've got the different numbers of atoms of each of those elements. So total, we've got 13 atoms here, right? 3, 6, 9, 12, 13. Yes? Okay. Let's look at the product side. On the product side, what's the first element that we have? Fe. How many Fe's do we have? Ladies? I am making a recording and I can hear your blabbering. Go away. Go away. Angie, I heard you. I want you to be quiet and go to your class. Let me finish this and then you can go. What's next? How many irons? What's next? We got oxygen. So I'm going to write O down here. How many? What's next? Hydrogens. How many? Then we got what? Na. How many? Okay, and then what? Chlorine. How many? We've got 2 because the 2 is multiplied by both things, right? Now, does this follow the law of conservation of mass? No, it does not, because look, the numbers here are not the same. These are not equal. So somewhere we made a mistake, okay? Because you need to have the same kinds of elements and you need to have the same number of each atom. So if I asked you on a test, does this equation prove the law of conservation of matter? Yes or no? Explain. You would work this out like this. And then if they're equal, yes, it does. If they're not equal, then no, it doesn't. Because the product side has 2 less atoms. Here we've got 13 atoms. Here we only have 11. That's not the same, right? 3 plus 3 plus 2 plus 2 is 10, plus 1 is 11. And on this side we have 13. The law of conservation of matter is not working here. Do you understand this? Yes?